Good morning, one and all. Today we are going to see about tools and frameworks which are used in artificial intelligence and machine learning. From that, first we are going to see about Raspberry Pi. It is a low-cost credit card-sized computer that is developed by Raspberry Pi Foundation. It runs in Linux-based OS. Example Raspberry Pi OS Ubuntu. It means Raspberry Pi is a small, affordable computer that is capable of running full-fledged operating systems and software stacks like Linux. It is well suited for AGI applications because it can run machine learning models locally and interact with sensors and actuators. So, it is in real-time applications, it is mainly used in real-time signal processing. Raspberry Pi handles real-time signal processing tasks such as video or sensor data acquisition. In that, we are using peripherals like cameras or sensors. It can process this data through AI models, making real-time decisions. What are the specifications and features in a Raspberry Pi? Raspberry Pi is an ARM-based CPU and GPU. It has 1 to 8 GB RAM for various models. CPIO pins for sensor and device interfacing, that is general purpose input-output pins for sensor and device interfacing. It supports Wi-Fi, Bluetooth, HDMI and USB port. It is compatible with Python and AI frameworks. Why we are using Raspberry Pi for Aiml? Affordable edge computing platform. It is affordable in edge computing platform. It supports TensorFlow Lite, PyTorch and OpenCV. It enables real-time interface and automation. It is useful for prototyping AI-powered IoT systems. These are all the setting up Raspberry Pi for AI projects. What are the steps? Install Raspberry Pi OS, configure Python and virtual environment, install AEML libraries, TensorFlow Lite, Scikit-learn, OpenCV. These are all the libraries in Python for AEML. Connect sensors and cameras for data input. Okay. In machine learning applications, it is used for image classification, speech recognition, predictive analytics, face detection and recognition, smart home automation. In deep learning applications, use TensorFlow Lite for lightweight neural networks because TensorFlow Lite is a small one. So it is used for lightweight neural network. Optimize model for low power devices. For example, object detection using Pi camera and TensorFlow Lite. AGI for faster decision making without cloud dependency. So, what are the conclusion on the future scope? Raspberry Pi makes AI accessible and affordable, ideal for students and researchers to experiment with AGI. In future, more powerful Pi model supporting on-device training. More powerful Pi models supporting on-device training. Okay, these are all the conclusion and future scope of Raspberry Pi in artificial intelligence and machine learning. Next, we are going to see about Arduino. It is an open source microcontroller platform. Open source microcontroller platform often used for IoT projects. It is a low cost, easy to perform and consumes little power. It is a low cost device and also it is easy to program. We can easily program an Arduino device and also it consumes less power. While not powerful enough to run complex machine learning models directly, it is a low power device but it can run complex machine learning models directly. It can interact with the sensors and perform basic data pre-processing. Okay, can interact with the sensors, that is input devices. It can easily perform the basic pre-processing operations, which is then sent to more powerful device. So basic pre-processing operations are done by Arduino, and then the output of that Arduino is given to Raspberry Pi or high-end model, more powerful devices. Okay. So it is developed by Arduino is developed by Arduino.cc, widely used for electronics, automation and IoT platforms. We can easily program in Arduino IDE or Python. Using Arduino IDE or Python, we can easily program Arduino device. In real-time applications, Arduino can collect sensor data and send it to the Raspberry Pi or cloud for processing and decision making. Arduino is used for and collect sensor data, pre-processing it and send it to the Raspberry Pi or cloud for other processing operations and decision making. Okay, it is a small microcontroller, so it is used for collecting the sensor data. What are the features in Arduino? It is a microcontroller, ATmega 328 or ATmega 2560. Digital and analog input pins are there. USB connectivity for programming. For programming, we are using USB connectivity. It supports sensors, actuators and communication modules. It is compatible for C, C++, Python and AGI tools. Why Arduino for AI and ML? Enables AI on low cost hardware. It supports TinyML because TinyML is a machine learning on microcontroller, small microcontroller. Works with TensorFlow Lite for microcontroller. It is useful for real-time decision making at the edge. Setting up Arduino for AI projects. What are the steps? First, install Arduino IDE. Add TensorFlow Lite for microcontrollers. Connect sensors. Train lightweight ML models and deploy to board. What are the applications in AIML? Gesture recognition, voice command recognition, predictive maintenance using sensor data, smart agriculture and home automation, then health monitoring. These are all the AIML applications using Arduino. Okay. Next, example project. We can detect keyword detection using Arduino. Collect voice samples, train a small neural network, deploy using TensorFlow Lite for microcontroller, run interface on Arduino Nano 33BLE, can sense the keyword. From the collection of voice samples, it can sense the keyword. Conclusion and future scope. Arduino AI, it is a smart and efficient edge devices. Promote learning and innovation in embedded AI. In future, more AI optimized boards, example Arduino Nicla, Potenta H7, these are all used Arduino. Okay. Next we are going to see about ESP32. It is a Wi-Fi plus Bluetooth enabled microcontroller with a dual core processor. Wi-Fi with Bluetooth enabled microcontroller. High speed and low power device, built-in wireless communication. ESP32 is a powerful microcontroller with built-in Wi-Fi and Bluetooth capabilities. It is suitable for IoT applications, gesture recognition, AI microcontrollers and all. And it can run lightweight AI models, especially when optimized with TensorFlow Lite. TensorFlow Lite. In real-time signal processing, ESP32 can process signals from connected sensors. It can process signals from connected sensors like temperature, motion in real time. It can also run simple machine learning models locally, making it ideal for AGI applications where cloud processing is not viable due to bandwidth or latency constraints. It can also run simple machine learning models locally. Simple machine learning models we can use it in local, not in cloud applications, making it ideal for AGI applications where cloud processing is not suitable due to bandwidth or latency constraints. Due to bandwidth or latency constraints.